All right, here is our video for the test review for test 1. What I have on the screen right now is the first section already showing the answers for domain and range for these 3 problems. These are more straightforward. I get the most questions from students for number 2, so I'll talk you through that one. But pause your video, check your answers with these. None of these are piecewise functions, so they're just you're reading the domain from left to right, the left boundary to the right boundary. If it's got a closed circle, it's a straight bracket. If it has an open circle, it gets a parenthesis. You're reading the range from the bottom to the top, so the least y value to the greatest y value. And again, if the least value is solid or has a closed circle, that value will get a bracket. And at the very top value, if it's an open circle, it gets a parenthesis. Okay, so what's happening for number 2 for domain and range? This is what we call a step function. And in this particular one, there's no break in the domain. So this is my farthest left value at 0, and my farthest right value is at 5. At 0, it's a closed circle. At 5, it's an open. And what I'm going to do is look if there's any x value between here that does not have a point on one of these pieces. So when I look at this first section from 0 to 1, there's no breaks in the x until I get here. There's an open circle. However, right above that, there's a closed circle. So at this x value of 1, there is still a point that is part of the function. So then I move to the right. It feels like it breaks again here at 2, but if I go right above it, there's a closed circle there, and that means I do have a value at x equals 2. And so if you keep doing that through each step, you realize that there is no break from 0 to 5 for the x values. So my domain is 0 to 5, where 0 is included and 5 is excluded. The range, however, does have breaks. So now we are looking at y values, bottom to top. So my least y value is right here at 0. My greatest y value is right here at 4. And so I'm going to be scanning now this way, left to right, to see if there's a break in the graph for the y's. And you can see as I go from bottom up, between these 2 sections right here, in between them, there is no part to any of the graph. So there's no piece of the function that covers these y values from here to here. So at 0, it breaks, and it doesn't pick up again until y equals 1 right here. And then it breaks and doesn't pick up again until y equals 3. And then the same for 4. So I would actually list the range as individual values at 0, 1, 2, 3, 4. If there was a continuous graph and then a break, I would write it in with a U notation. I'm just making this up, so this isn't part of the problem, but let's say the range or the domain was continuous. This is not continuous, it's discrete. We would write the interval for one piece and then join it with the interval for the next piece. And number 5 is just answers will vary here. I drew a parabola opening down. So this has a domain of negative infinity to positive in a range with y's less than or equal to 5. So here's y equals 5, and every other y value on this graph is below that. Okay, on the back. For this section up here, we're just stating we're describing the transformations being done to the function. So if you look at this first one, x minus 4 parentheses squared plus 5, that squared tells me that the parent function was x squared. And 2 changes have happened to this, a minus 4 with the x and a plus 5 on the outside. So remember that anything that happens inside with the x is going to make the graph do the opposite. So in this case, it's going to go right 4. And anything on the end or outside is going to affect your y values. That's going to make it go up 5. So pause the video and try number 7 and number 8. So here are my answers to 7 and 8. This was a parent function of absolute value. A negative outside the absolute value means your y values are changing sign from positive to negative and negative to positive. That's going to reflect your graph over the x-axis. Then insiders lie, the +1 is going to make your graph go left 1, and then -3 on the outside is going to make your graph go down 3. And what I mean by reflection is this negative out front, if your y was positive, it's now negative. If it was negative, it's now positive. So that's what we mean by a reflection over x. A reflection over y in this situation would look like this. A negative on the inside that goes with the x. So what that's going to do is take your x values. If your x was positive, it's going to make it negative. If it was negative, it's going to make it positive. And that's reflecting over the y-axis. And then, okay, sorry, I should have just waited till I got to this problem. That's what's happening here. The x has the negative directly in front of it and inside the function symbol of this, it's inside with the radicand right here. It's not on the outside. A negative out here in front of the 2 is what I mean by outside, and that would change your y's. A negative on the inside changes your x's. And changing your x's again reflects it over the y-axis. And then a 2 in front of your function takes your y values and multiplies them by 2, so we would call that a vertical stretch of 2. So down here, what we are going to be doing is setting up tables for transformations. We're going to use our original x and y values for our parent function. So I want you to pause the video, identify each of these parent functions, and then fill in their parent or original xy values. Okay, so here are my tables. I've identified the parent function, and I've included our parent xy values before any transformations are made. And what we're going to do next is take a minute to figure out in which places the original function has been changed and how that changes the shape of my original graph. And we're going to make new xy tables and then use that for our graph. So in this situation, we have and actually let me write our general form here. Anything directly in front and on the end of the function changes your y values. Anything inside near the x changes your x, but you're going to do the opposite. So if you're adding or subtracting, you'll do the opposite of that. If you're multiplying, you'll divide by that. So if you're multiplying by a fraction, you'll end up dividing by that fraction or multiplying by the reciprocal. Or if you're multiplying by an integer like 5, you'll end up dividing by 5 or multiplying by a fifth. So I'll talk about that down here. So in this first one, this 2 is not inside any parentheses with the x. So we're going to consider this as in the front of the function, and that's going to change your y values. So that's going to take your y values, multiply by 2, and then this -4 at the end is going to take them down 4. And so my x's aren't going to change. They'll stay this. And each of these values here, I'm going to do these functions to the y. I'm going to take each y value, multiply by 2, and then subtract 4. You're going to follow your order of operations. So you take a minute, do that with your x and y values, pause your video, and then graph your new shape. Oh, I'm so sorry. Did not know I had to pause the video. I think I've been eating popcorn. So sorry. That's my bad. That's embarrassing. So over here on number 10, okay, I'll talk about this one in a second. On number 10, let's talk about the changes. You see how this 1/3 is in the parentheses with the X? So that's what I mean by this B value that's inside with the X. So we are going to do the inverse operation of that to our X values here. So we're going, instead of multiplying by 1/3, we're going to divide by 1/3, also known as multiply by the reciprocal. So we're going to multiply by the reciprocal of 1/3, which is 3. So I'm going to take all of my x's and multiply them by 3. So each of these times 3. And then this 1 is outside the parentheses. It's at the end. That's a k value. That's going to take all my y's and add 1. So in a minute, I'll give you some time to do that math to your x's and y and shape your new graph. But let's talk about these changes over here as well. So you'll notice we have this negative in front of the function. That's going to change my y values, multiply them by a -1. And then this 2 and this -1 are both inside the function with the x, so we're going to do the opposite of them. If I'm currently multiplying by 2 and I want the reciprocal of that, I'll be multiplying all my x's by a half instead. So 1/2 times all my x's. And then I'll be subtracting 1 from them. So your job now is to pause your video, do all these changes to your x's and y's, and then graph your new shapes. Remember that the original shape for x squared is a parabola, for x is a linear, and then for absolute value looks like this shape. So you pause your video and do that for a few moments. All right, here is all of my math and my new shapes. So take a minute, pause the video if you have to, and compare yours to mine. For this next section, we are using the shapes and how they have transformed to create the equation for ourselves. So we are trying to fill in the A, B, H, and K values where appropriate. So I notice in this first graph that my vertex went over 3 up 1. That is my H and my K. There's no reflection over the x-axis, so I know my A is not going to be negative. And then I'm going to look for a vertical stretch. Since I can go over 1, up 1, and land on the graph, my y values and my x values were not changed or multiplied by anything. So I know that I don't have an A or a B besides just being 1. So, and the original function is an x squared. So here's how I put all that together. X minus 3 parentheses squared plus k. So remember, you're putting the squared on the outside of the parentheses. And then I'll talk about this next problem and the last two in a different video because I'm running out of time on the free version of this one. I only get 15 minutes, so look for the second video for the remaining problems.